Welcome back. As you can see, I haven't even rubbed what I did last time. I'm going to start now with some more revision questions on double angles, T formula and everything. So it's going to be revision session 3, I can call it as. Yeah. Let's prove some identities. Show that. Oh, by the way, my name is Sosale Mohana. I'm a maths teacher, and by now most of you know that I've had a long stint at teaching maths across the globe in India, Kenya, and the UK. And I'm just using my retirement time to prepare these lessons for the benefit of students like you who might want to revise and reinforce what they have learned in school. Okay, so let's come back. So to prove some identities using double angles. Cosecant 2x minus cot 2x equals tan x. Cosec 2x minus cot 2x equal to tan x. Obviously, it's easier to use double angle formulae in terms of a single angle than the other way. So therefore, let's start from the left side. Cosec is 1 over sin 2x minus cot is cos over sin. Sin 2x is a common LCM, so up to here, most of you will arrive at the answer. Now comes the question. For sin 2x, you don't have a choice. You just have one formula. 2 sin x cos x. You absolutely don't have any choice there. But for cos 2x, there are 3 formulae. Cos squared x minus sin squared x. 2 cos squared x minus 1. 1 minus 2 sin squared x. By the way, you can use any one of those and simplify to arrive at the answer, but we need to be clever. Tan is sin over cos. In the denominator, I can't help. I have a cos, but I have a sin as well. I can't help. But in the numerator, at least I can keep only sin and no cos. So I will use 1 minus 2 sin squared x. As I said, you can write 2 cos squared x minus 1. Perhaps later on you'll have to use cos squared as 1 minus sin squared. So it's unnecessarily why waste time. So it's 1 minus 1 plus 2 sin squared x over 2 sin x cos x. So that will be 2 sin squared x over 2 sin x cos x. As you can see, the 2's can be cancelled. 1 sin square can be cancelled with another sin. So I'm left with sin x over cos x, which is tan x. Yeah, good. Let's look at another question. Let me call it as question 2. I'm just I made up questions at random just to solve. Cos A sec 2a equals tan 2a cosec A. Cos A sec 2a equal to tan 2a cosec A. I have made up this question, but I'm not too sure whether this will work or not. Okay. What is sec? No, we have to do a bit of adjusting here, as we'll see. This is left side is cos A over cos 2a. Yeah. Now, this is where a bit of thinking and you get the answer in one step. Look, to get tan 2a, I need a sin 2a, correct? I have a cos 2a, so I will forcibly bring a sin 2a. Okay. But that will change the question. So if I multiply by sine 2a, I must divide by sine 2a. Now what is sine over cos? Tan 2a cos a over I think there is a problem. I think I should have a 2 over sine 2a is 2 sine a cos a. See what I did? I kept this. Sine over cos is tan. This 2 should be there. 2 cos a. And then sine 2a I wrote that. This 2 and that 2 cancels. Cos a and cos a cancels. I get tan 2a cosec. Yeah. See, I made up the question, so I'd forgotten to bring the 2. I think, no, I have written the 2 there. I've forgotten to bring it here. But what if we start from the right hand side? It's the reverse process. Start from there, write like this, and then 2 sine a cos a, and then I think it should work. Let us see if it works the other way. Suppose I start from the right hand side. It is sine 2a, oh yeah, it works, over cos 2a times 1 over sine a. That is 2 sine a cos a times 1 over cos is sec 2a over sine a. Sine a cancels. I get 2 cos a sec 2a. Yeah, it works both ways as well. So again, as I told you last time, I can keep doing identities and equations for the next year or 2. Still, we won't exhaust all the questions that are available. So my job is only to show you some varied examples so that you get the hang of it. That's all. Now, let me solve as usual identities, equations. Elimination. Shall we do elimination first? Yeah. Eliminate theta from x equal to 2 cosec theta, y equal to sine 2 theta. Sine 2 theta contains 2 sine theta cos theta. Cosec is connected to sine theta. Cos is connected to sine theta. So I need to find sine theta. So can I say x equal to 2 over sine theta? So sine theta equal to x over 2. But to find sine 2 theta, I need cos. Cos theta is root of 1 minus sine squared theta, which is root of 1 minus x squared over 4, which is root of 4 minus x squared over 4, which is root of 4 minus x squared over 2. Sometimes use the substitution x equal to 2 cosec theta to integrate sine 2 theta d theta, something like that. Then you should know how to convert them. Let's hope for the best. So therefore, y equal to 2 sine theta cos theta. So that is 2 times I wrote and you also agreed. It is a bit stupid. See, this way sometimes we go wrong. Sine theta is 2 over x. I'm an idiot. Cos theta is root of 1 minus 4 over x squared, which is root of x squared minus 4 over x squared, which is root x squared minus 4 over x. Please, I have seen A-level students writing this. Root of x squared minus 4 is x minus 2. So my answer to that will be root of 25 minus 16 is root 9, which should be 3. Your theory says 5 minus 4 is 1. So you're saying 3 equal to 1, which is wrong. You cannot take an individual square root when it is a plus or a minus. Please don't forget that. I've come across that very easily. I've come across that very many times when I was marking or teaching and giving tests at A level, not even GCSE. Sin theta is 2 over x. Cos theta is root of x squared minus 4 over x. So y equal to 4 root x squared minus 4 over x squared. It's just again playing around with the formula and not committing stupid errors the way I did. Be careful. Alright. Then I'll have to take an equation, obviously. So let me take an equation. Solve for minus 180 less than or equal to theta less than or equal to 180, 10 sin theta cos 2 theta equal to 3 sin 2 theta minus sin theta. Woo! Okay. Sir, there are so many formulas for cos 2 theta. Which one do I use? I don't know. The best is, the one choice I don't have is sin 2 theta. So let's use the only formula we know for sin 2 theta. Number one, always get an equation as something equal to 0 so that you don't unnecessarily cancel. So this I can't do anything. Minus 3 sin 2 theta I'll write as 2 sin theta cos theta, and the other one plus sin theta equal to 0. Now what do you see? I see a sin theta, I see a sin theta, oh that's cos 2 theta, and I see a sin theta. Remove sin theta out, I get 10 minus 6 cos 2 theta plus 1 equals 0. What did I go wrong? No, that's correct, that's correct. I rewrote, sorry, when I copied, good, it came up. When I copied this, I wrote this as only 10 sin theta. I forgot to write cos 2 theta. It is not considered a misread because I had written it there. When I copied, I went wrong in copying my own work. So it's not a misread, you lose all the marks. If I was doing this in the exam, I would have lost all the marks. I'll have to restart this. I'm sorry. That's 10 sin theta cos 2 theta minus 3 times 2 times sin theta cos theta plus sin theta equals 0. Please don't divide by sin theta, but remove sin theta as a common factor. I am left with 10 cos 2 theta minus 6 cos theta plus 1 equals 0. See, life is easier now. So, I got 1 sin theta equal to 0. Here, I've got a cos 2 theta and a cos theta. So, 10 times 2 cos squared theta minus 1 minus 6 cos theta plus 1 equals 0. So, it is 20 cos squared theta minus 6 cos theta minus 9 is 0, isn't it? 10 2s are 20, minus 10 plus 1 is minus 9. Okay? 20 times 9 is 180. Then, anyway, we shall see. Doesn't matter. Whatever is there is there. So, therefore, cos theta equal to 6 plus minus root of 36 minus 4 times 20 times 9 whole over 40. If I am completely correct, I don't have to quote the formula. But if I have gone wrong, boom, then I will lose all the marks. So quote the formula. A is 20, B is minus 6, C is minus 9. You see, I would have lost the mark because I forgot to write a minus 9. Very good. So cos theta equal to 6 plus minus 720, 756, isn't it? 9 4s are 36. 36 and 20 is 720. 720 is 756. Is 756 a perfect square? I don't think so. 756 square root. I don't think it's a perfect square. 729 is 6 root 21. Okay. So 6 plus or minus 6 root 21 over 40. So cos theta equal to 6 plus 6 root 21 over 40. You don't have to simplify. 6 minus 6 root 21 over 40. Root 21 is about 5. No, 4 point something. So 24 plus 630, that's possible. Both answers are possible. So therefore, I need to find the decimals. 6 plus 6 root 21 equal to that, divided by 40 equal to that, shift cos answer 33.13, 33.1. And the other one is 6 minus 6 root 3 equal to that, divided by 40 equal to that, shift cos equal to 96.3. Right? So therefore, I'll just leave it there once I write the formula. I know you're clever enough now to write the answer. So therefore, theta equal to, for this one, it is 0, minus 180 and 180. Those answers are there. For that one, theta equal to 360n plus 33.1, 360n minus 33.1, 360n minus 96.3, 360n plus 96.3. So you got 4 answers. Now put n as 0, or let me finish it. It is 33.1 accepted, minus 33.1 accepted, minus 96.3 accepted, 96.3 accepted. Beyond that, it's not going to work. Because if you put 1, it's going to be more than 180. If you put n as negative 1, it will be less than minus 180. So those 4 plus these 3, there are 7 answers for that question. Yeah. Good. I have taken 18 minutes. So I think I will stop here. Because if I do the T formula and the A cos x plus B sin x, it will be more than 25-26 minutes. So I will stop at this stage and continue in the next lesson. Okay. That will be the last lesson on revision. I'll see you in the next lesson if you come back. Otherwise, nice knowing you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.